In this video, we will be calculating the present value of an annuity. You will know if you've mastered this if you can calculate the present value using the compound interest formula backwards and calculating the present value using a table of present value interest factors. So what is present value? Present value, often in the form of a lump sum, that is what we need to deposit now in one lump sum to reach the same future value as investing small amounts regularly with the same rate and period. Let's unpack that. So if we pause for a moment and just recognize that we can place our money into an investment in two separate ways. We can either do small amounts regularly, which is an annuity, like putting $100 in an account at the end of every month, or we can just put one lump sum in an account and leave it there. And that is just a compound interest investment. This lump sum investment is often called the present value. And we can calculate the future value if we know that present value using the future value formula. And vice versa, we can calculate the present value if we know that future value. And we do that by rearranging the formula to find the present value. So how do these two ideas connect? Present value and future value. If I want to know what the future value is, I'm asking, what would my investment be worth in 20 years if I deposit $1,000 at the end of each year? If I want to know what the present value is, I'm asking, what would I need to invest now to have the same amount in 20 years as if I invested $1,000 each year? So let's connect those two questions to form a definition here of present value. The present value of an annuity is the single sum that could be invested at the start to produce the same return as an annuity, e.g. an investment with ongoing deposits. So let's look at an example or a couple of examples in order to unpack this a bit further. So if we're wanting to calculate the present value of an annuity using the formula, we can do this if we have or know the future value. So if you know the future value, you can find the present value of an annuity. And we can use this rearranged formula to do that. E.g., Cecil wants to have saved $1,600 in 5 years. What single amount needs to be invested today into an account earning 6.5% per annum to achieve this goal? So, we want to have a future value of $1,600, and we want to have that in 5 years' time. What single amount needs to be invested today? So, what is the present value that we need if we're going to be earning 6.5% per annum in compound interest? So using our formula, present value equals 1600 divided by 1 plus 6.5% for 5 years. Evaluating that, we get 1167.809, which in dollars and cents is $1,167.81. So we would need to invest that amount in order to have a future value of $1,600 in 5 years. So therefore, we need to invest 1167.81 today. Now, if we want to calculate the present value of an annuity, but we don't have the future value, the only way we can do that is if we know the regular deposits. So if we don't have the future value, but we know the regular deposits of an annuity, we can use a table of present value interest factors. In the previous lesson, we used a table of future value interest factors, and the process in this part of the topic is exactly the same. We determine the time period and rate of interest. We find the intersection point in the table to get the interest factor, and then we multiply. So the present value is going to be found by multiplying the interest factor by the regular deposits. Let's look at an example. The table gives the present value interest factors for an annuity of $1 per period for various interest rates and numbers of periods. So we've got a table here looking similar to the future value table, except that it's clearly labelled that it's a present value interest factors table. It's got rates along the top, and it's got periods along the side. And so we're going to need to find the rate and period in order to select the correct value from the table. Let's look at the question. Oscar plans to invest $200 each month for 74 months. His investment will earn interest at a rate of 0.00080 per month. Use the information in the table to calculate the present value of an annuity. So the $200 each month, that's our regular deposit. And we're going to do that for 74 months. So 74 is our N, and our rate is 0.0080. Now let's use the table to find that value out. So we've got 0.0080 and 74. So the value we want from the table is that intersection point, 55.68446. Now for the calculation. The present value is equal to 55.68446 times by 200. Which gives 11,136.892. in dollars and cents is $11,136.89. And so the present value of the annuity, or the single lump sum that will give the same as $200 each month for 74 months, is $11,136.89. To finish off, we're going to just have a look at these two types of investments, the annuity and the single lump sum. So we've had a look at, in that previous question, two methods of investing. So if you look on the left-hand side here, we're going to have a look at these two methods. And then on the right-hand side, we're going to consider, well, which is better? So one pathway in investing is just by putting some lump sum in an account and leaving it there for 74 months. And you end up with a future value. The equivalent, or another way of getting the same future value, is to deposit $200 monthly for 74 months. So every month we go 200, 200, 200, and we keep adding those in, and we get the same future value. So both of these methods give us the same financial outcome at the end. Either the lump sum of $11,136.89 or 200 monthly for 74 months. So which of these is better? There's two ways we can think about this. One, cost, and two, practicality. Well, the cost of doing the lump sum is just depositing that one amount into the account, the $11,000. What's the cost of the annuity? Well, it's $200 every month for 74 months. So to find that, we do 200 times by 74. It's going to cost $14,800. So from the perspective of how much money you've got to put in, it's cheaper to get the same end result. It's cheaper to use option one, the lump sum. How about practically? Well, unless you happen to have some sort of lump sum sitting around, that might be a gift or some savings sitting there, it's much more practical to deposit 200 each month. So option two is more practical. So, which is better? Well, if you've got a lump sum, it's going to be a cheaper return than holding on to that amount and slowly putting it in. However, we're less likely, or it's less viable or practical for us to have large amounts of money sitting around, and so it's more practical for us to deposit 200 each month. So in this lesson, we have looked at present value. We've calculated it in two ways. One, when we have the future value, we can just use the compound interest formula backwards. Or, if we don't have the future value, but we know the regular deposits, we can use the present value table of interest factors to find the present value.